Module 3, Numerically Summarizing Data, Section 3.1, Measures of Central Tendency. We'll look at these objectives in this section. Objective 1, we want to determine the arithmetic mean of a variable from raw data. The arithmetic mean of a variable is computed by adding all the values of the variable in the dataset and dividing by the number of observations. The population arithmetic mean, pronounced mu, looks like a U with a little tail in front, is computed using all the individuals in a population. The population mean is a parameter. The sample arithmetic mean, pronounced x bar, is computed using sample data, and this is a statistic. If our x values are the n observations of a variable from a population, then the population mean, or mu, is given by this formula here. We take the sum of our observations and divide by the total number of observations. Notice we have a similar formula for x bar, our sample mean, but we use a small letter n for the observations coming from a sample, since it's not the entire population. But we still sum all of the observations and divide by the total number of observations in our sample. So let's look at an example. We want to compute a population mean and a sample mean. The following data represent the travel times in minutes to work for all 7 employees of a startup web development company, and here we see them listed. So we want to compute the population mean of this data. The population mean, remember, is represented by mu, and it's going to be the sum of all of our observations divided by the total number of observations, and we see that we had 7 employees. So we want to sum each individual value and divide that by the total number of values. So when we add those all together, we see that we get 174 divided by 7, which will give us about 24.9 minutes. And that's the population mean for this data set. Now we wish to obtain a simple random sample of size n equal 3 from our population of 7 employees. And we'll use this sample to determine a sample mean. Then we find a second simple random sample and determine the sample mean of that. So using the calculator, we can obtain a sample of size 3. So we enter our seed, we hit store, then we hit math, and arrow over to PRB and hit enter on rand. Then we hit enter and we've stored that value as our seed. Now we hit math again, go over to PRB, and we'll hit number 5 for rand int, from 1 up to 7. So we want the digits from 1 to 7 because we had 7 data values. We hit enter and we see we get a 5. If we hit enter again, we get 2, and then we get 6. And you see this screen is on our slide. So when we list our data values, we number them from 1 to 7, and we see that from our random generator, our calculator, we want to use the 5th, the 2nd, and the 6th number in our data set, and we want to compute a sample mean from that. So the 5th number was 5, and then we'll add the 2nd number, which was 36. Then we add the 6th number, which was 26. And we'll divide that by the total number of values in our sample, which is 3. So you see then when we evaluate it, we will get the value of 22.3. We'll do this again. We use a different seed, just entered 789 this time, and found a random sample 2, 3, and 6. So we'll compute the sample mean of this sample The second value in our data set is 36, the third was 23, and the sixth was 26. We divide by 3, and we see that we'll get a sample mean for this sample of 28.3. Objective 2, we want to determine the median of a variable from raw data. The median of a variable is the value that lies in the middle of the data when arranged in ascending order. We use a capital M to represent the median. And here are the steps in finding the median of a data set. First, we arrange the data in ascending order. The second step, we will determine the number of observations, n. Step 3, we will determine the observation in the middle of the data set. If the number of observations is odd, then the median is the data that is exactly in the middle of our data set. So that means that the median is the observation that lies in the n plus 1 divided by 2 position. If the number of observations is even, then the median is the mean of the two middle observations in the data set. That is, the median is the mean of the observations that lie in the n divided by 2 position and the n divided by 2 plus 1 position. So let's look at an example. We want to compute a median of a data set with an odd number of observations. So again, we have our data set from our startup web development company with the travel times for our 7 employees, and we want to determine the median of this data. The first step then is to arrange the data in ascending order. So we start with the smallest value and go up to the largest value, and here we see this now. Step 2 is to determine the number of observations. So we see there were 7. Since it was an odd number, we know that the data value, which is right in the middle, will be our median. So m will be 23. But if you remember, we also use the value n plus 1 divided by 2 would be our position. So n was 7, so we have 7 plus 1 divided by 2. So we have 8 divided by 2, or the fourth position. So the value in the fourth position is our median. So we look and we count, and we see that the fourth value was our number 23. So the value in the middle is our median. Now we want to look at an example where we compute a median of a data set with an even number of observations. So suppose the startup company hires a new employee. The travel time of the new employee is 70 minutes, so we add it on to the n now. And we want to determine the median of our new data set. Remember, the first step is to put them in ascending order. The value of 70 is higher than any of the other previous values, so we can simply add it on to the end of our list from our previous example in this step. Step 2, we now have 8 observations. And for step 3, we'll determine the observation that's in the middle. So since there's an even number, we're going to find the mean of the n over 2 position and the n over 2 plus 1 position. So n over 2, remember n was 8, so we want to do between the 4th and the 5th position. So numbering our values, we see that the 4th position is 23 and the 5th position is 26. So we add those together and we divide by 2 since there are 2 values. And we see that we get a value of 24.5 minutes for our median. So the median with an odd number of observations will actually be a value in the data set. But the median when we have an even number will be an average of the two middle. So it's not an actual value in the data set in this case. We can use the calculator to determine the mean and the median. The first step is to enter the raw data in our first list by pressing Stat and selecting 1 for edit or hitting Enter on edit. And we enter our values in list 1. We type the value and we hit Enter. And notice that I entered the values exactly as they were listed originally. There's no need to put them in ascending order for the calculator method. Next, we press Stat and highlight the Calc menu, so we arrow over, and we'll select number 1 for one variable stats. We hit Enter on it. With the one variable stats appearing on the home screen, we simply press Enter. And we see in our list the value X bar is at the top, which is approximately 24.9 when we round. Notice the arrow down by the letter N here. If we use our down arrow, we can arrow all the way down till that down arrow disappears and we see the rest of that list for one variable stats. Notice that right in the middle now is the letters MED. That is the median, which was 23. And if you recall from our first example, that's the value that we got for our median. So the median is 23. So the calculator is very handy when finding these values. Objective 3, we want to explain what it means for a statistic to be resistant. We're going to look at an example. This was the travel times of our 7 employees for our startup web company. We're going to suppose that our new employee is hired that has a 130-minute commute instead of the 70-minute commute. So how does this impact the value of the mean and the median? Remember, the mean before the new hire was 24.9 and the median was 23, as we found on the calculator. So let's use our calculator, go back into our list, Stat, and Enter. We're going to arrow down to the bottom. We're going to add the value of 130. We'll go through our steps again. We hit Stat, go to Calc, and hit Enter, and then hit Enter again to do it. We see now that the mean is 38, and if we arrow down, we find that the median is 24.5. So notice that the median didn't change that drastically, but the mean increased quite a bit. So let's look at what that means. A numerical summary of data is said to be resistant if extreme values, which are very large or very small, relative to the data, do not affect its value substantially. So in our example before, we noticed that the median was not affected, so it would be resistant. However, the mean was greatly affected, substantially, and so it would not be resistant. Let's look at this relation between the mean, the median, and our distribution shape. If the shape is skewed left, as we see in our picture A here, then the mean is substantially smaller than the median. If our shape is symmetric, as we see in picture B, then the mean is roughly equal to the median. And if it is skewed right, as we see in picture C, then the mean is substantially larger than the median. So let's look at another example describing the shape of the distribution. The following data represent the asking price of homes for sale in Lincoln, Nebraska. We want to find the mean and median and use those values to identify the shape of the distribution. Verify your result by drawing a histogram of the data. So you can compute those values any way you like. We can put them in the calculator or do them by hand, but we get that the mean asking price is $168,320 and the median asking price is $148,700. So notice that the mean is substantially larger than the median, which would indicate from our pictures before that the distribution is skewed right. And here we see our histogram of our data, and notice that it is skewed right. The majority of the values is on the left side as it trails down to the right. Objective 4, we want to determine the mode of a variable from raw data. The mode of a variable is the most frequent observation of the variable that occurs in the data set. A set of data can have no mode, one mode, or more than one mode. If no observation occurs more than once, we say the data have no mode. So let's look at this example. We want to find the mode of a data set. The following data represent the number of O-ring failures in the shuttle Columbia for its 17 flights prior to its fatal flight. We want to find the mode number of O-ring failures. So we see that we have 11 values that are equal to 0. We have 4 values equal to 1, and we have a value of 2 and a value of 3. So the value that occurs the most is the mode. So the mode in this case would be 0. In this example, we want to find the mode of exam score data listed below. So here we see we have no value occurring more than once. Every value occurs exactly one time. So we have no mode in this case. So let's look at the 3 measures of central tendency that we've just discussed. We looked at the mean, the median, and the mode. To calculate the mean, remember it's the sum of the data values divided by the total number of values. And we use this when the data are quantitative and the frequency distribution is roughly symmetric. Since it is not a resistant value, we need them to be symmetric to use the mean. The median, remember, we found by arranging the data in ascending order and dividing it in half and using the middle value. We'll use this when the data are quantitative and the frequency distribution is skewed left or right. To find the mode, we tally the data to determine which one is most frequently observed. And we use this value when we want to know the most frequent observation, or also when the data are qualitative.